Now, since we talked about the physical quantities, so whenever we measure something, whenever we measure the length or the mass or the time, there will always be in the real life, whenever we want to measure something, there will be an error in the measurement. So any measurement without the knowledge of the uncertainty or without the knowledge of the error is meaningless. If you do not know if there is an error or how much is the error, so the measurement is meaningless. So we talk about the error and uncertainty. So the error in the measurement, for example, I have a rod, small rod, for example here. I want to know how much is the length of this rod. So what I will do, I will just take a meter rod. A meter rod is looking like this. So it has a long thing, and then it has the scale. So this is a standard. So what we do, we read these scale standards, and then we compare it. When we compare it to, so we compare this rod to the scale, so the standard scale, which is a meter rod, and then we know how much is the length of this rod. But we want to know what's the error. Why? Because the error could be because of my own mistake, it could be because of the systematic mistake, poor calibration, for example. We can have a random error. For example, what is random error? If I measure this, the length of this rod once, and then I get, for example, 5 centimeter, 5.2 centimeter. This is just a random number. This is just a guess. So, and then next time, if I measure it again, so I have a 5.3 centimeter. Next time, if I measure, I get 5.4 centimeter. And so this is a random error. So it will happen because whenever we measure something, we cannot measure something extremely accuracy. It depends. It depends on the measurement, on the instrument that we use. So every measuring instrument has a least count. What is least count? For example, if you zoom this meter rod, you will see lines, big lines. So from here to here, so this is not to scale. So 1, 2, 3, and then we have a small lines here, so 10 lines here. So this is, for example, 1 centimeter. So here, from here to here, so we have 1 centimeter, then 2 centimeters, 3 centimeters. But we have these small lines which are millimeters, So if you want to measure something which is larger than these millimeters, we can measure with this instrument. What if we have something really small, which is smaller than this division, so which is smaller than the millimeter, for example, the thickness of the hair. So we cannot measure it with this instrument, there will be huge error. So this is the concept of the error. So if we want to measure a small object here, very small, which is smaller than the centimeter, we will have a huge error. Because, for example, what if I have an object which the length is ending on neither of these divisions here, which is in the middle. So how do we know what is the exact length of this object? So for that we use some sensitive instrument which could be, for example, vernier caliper or screw gauge. So those instruments are more precise because their least count is much smaller than the millimeter. So this is the concept of the error. So any measurement without the knowledge of uncertainty or the error, it's meaningless. For example, so the least count is here. is 1 millimeter. So what do we do? If, for example, I measure the length of this rod here with the help of this meter rod, and I get, for example, 5.2 centimeter, but I should not write 5.2 centimeter. What I should do, 0.1 centimeter. So what I got was 5.2 centimeter, but it can also be 5.3 or 5.4 centimeters, so plus minus, so it can go up and down because of this least count here. So we cannot be 100% precise. So this is the error. So we just write in physics whenever we measure something. So this is the example for the length. So the same is true for the time, for the temperature, for all the measurable quantities, the physical quantities. So this will tell us that this can be, so for example, so this value I measure it, so it can also be 5.1 or 5.3. So we always have to write the error whenever we measure something in our labs or whenever we measure in physics something. So the error, the knowledge of error or uncertainty is always important when it comes to measurements. Now we come to the precision. Precision and accuracy. So the precision is defined by the instrument, and the uncertainty is the percentage of the error. So how much is the percentage of the error? So the precision is defined by the instrument. For example, if we want to measure, the length of this rod with this meter rod, and then we measure the length with the vernier caliper. Since vernier caliper is more sensitive, the least count is extremely small, much smaller than the meter rod. So the vernier caliper is more precise than the meter rod. Similarly, we have the screw gauge. Screw gauge is more precise than the vernier caliper and the meter rod. So with the vernier caliper, we can measure very small objects, the length of very small objects. Similarly, with the screw gauge, we can measure the length of even the thickness of your hair. So the diameter of your hair. So here I will give you an example. So I have, for example, here a rod. So I have here a rod, and with the meter rod, so I take a meter rod, meter rod. So this is a normal rod, and we measure the length of this rod with the meter rod. So I found, for example, its length is 25 plus or minus 0.1 centimeter. So why do we write 0.1 centimeter? Because the least count means here the smallest division is the 0.1 centimeter or 1 millimeter. So 1 millimeter. So what do we do? And then now we want to see what is the percentage error. So what is the percentage of this error? So what we do, so percentage error. So 0.1 centimeter divided by 25. So this is the 25, which is the length of this object, which is measured with the meter rod, multiplied by 100. So we get 0.4 meter percent. So this is the error is 0.4%. Now we take a vernier caliper. Vernier caliper. So vernier caliper, the least count is 0.01 centimeter. So which is 10 times better than, which is 10 times more precise than the meter rod, because it can measure very small small lengths. And now, so for the meter rod, we took this big rod which was 25 centimeter, but for the vernier caliper, since we can measure very small objects, we do not have to measure 25 meter rod, so we can also measure very small objects. So for example, I have a very small object which is like tiny, and I measure it with the vernier caliper, and I get 0.45 plus or minus 0.01 centimeter. So why do we write this plus or plus minus here? Because it can be 0.45 plus this one, or 0.45 minus 0.01 centimeter, because this is the least count. We can make this mistake. That's why we have to write the error here. And now we do the same thing, we just calculate the percentage error. Here, so percentage error is 0.01, 0.45 multiplied by 100, so we get 2%. So the measurement done by the meter rod, so we compare these two, so we have to understand the precision and the accuracy. What we said, that the precision depends on the measurements of the measuring instrument. Since this vernier caliper has a smaller least count, so this vernier caliper is more precise, so the measurement done by the meter rod is less precise, because it has the bigger least count, but this one is more precise here. The vernier caliper is more precise compared to the meter rod, because it has the smaller least count. So how do we distinguish between the precision and the accuracy? So a precise measurement is that one which has a less absolute uncertainty, and the accurate measurement is the one which has the less fractional or percentage error. So now we talked about the errors, the uncertainty. Why is the error important, or why is the uncertainty? So error and uncertainty is the same thing. So why are they important in the measurements? So we always have to give the error whenever we measure something. But now we come to the real measurements, when we measure something. For example, so how do we add errors? For example, we have so the addition, and subtraction. Subtraction. So if we, for example, measure two different lengths with the meter rod, for example, or any other object. So here we will just take an example of the meter rod, because its uncertainty, its uncertainty or the least count is 0.1 centimeter. We just take this example. We can use the same thing for any other instrument. So we measure, for example, x1 is 10.5. So this is the measured value, but just to be on the safe side, we write an error. So this error is the least count of the meter rod. And then we have the x2, which is 26.8 centimeter, but we have to write an error. So what if we have to add x1 plus x2, or we have to subtract? What do? We have to add these errors. So if you want to subtract, if you want to add or subtract two different values, two calculated values, we have to add the errors. For example, I will just subtract these two. So we have the x, for example, x equals x2 minus x1. So we have the x2, we have the x1. So we will have, if we subtract 10.5 from this value, so we will get 16.3. But as we said that we have to add the errors, because now we have two different errors, they will add up to the new value. So they will not be less precise then. Plus or minus 0.2 centimeter. So this is little bit you might see a strange thing, because we subtract these two values, calculated values, but we add the error, because this was measured by the meter rod and this was again measured by the meter rod. So this was the error and this was again the error in the measurement. So this was the possible error. So if whatever we do, we add or subtract, so the error will add up. So because we have the two different measurements, so the error will add up. So multiplication, now we come to the multiplication. Or division. For example, we have the resistance equals voltage divided by current. So what we want to do, we want to measure the resistance of a resistor, for example, or any electronic object, electronics. So for the resistance, we need to measure the voltage and the current. So for example, we in the lab, we go to the lab and then we measure the voltage. So we have the 5.2 plus minus, we measured the voltage, which is 5.2, so 0.1 volts. So the instrument, the least count is this one. So the least count means, so this instrument, which is a voltmeter, is able to measure up to or down to 0.1 volts. It cannot measure below this value. So this is called the least count. And now we have the current, which is 0.84 plus minus 0.05 ampere. So here we have to add the percentage. So for the division, so here we have the division here. So this is the case of division. So for that we have to first calculate what is the percentage error, and then we add the percentage error when it comes to multiplication or division. So percentage error in V, so we have the 0.1 divided by 0, so this is the 0.1, which is then the measured, so we write the measured one and then multiply by 100. So this is how we get the percentage error. so which is the 2%, and then we calculate the percentage error in current, which is 0.05 divided by the measured value, 0.84 multiplied by 100, which is equal to 6 moles. And now for the resistance, so we have the 5.2. so here we can see here we have the 5.2 which is measured, and then 0.8, so there is another point here. So voltage divided by current, so we have the 8.4. So this is equal to, so when we calculate this, so we will get 6.1 volt ampere minus 1 plus minus 8% error. So we just add up these two and then we write the percentage error. So for the multiplication we add the percentage error. So for the power case, so when we have the for power factor, what if we want to measure something which has the power? For example, if I ask you to measure the volume of some object, so we have the volume, for example, this is the formula from the volume of the sphere and the R cube. So what we see here, we have the radius. So we have an object which has a radius, and then we want to calculate the volume of that object. So this is to our constant pi. We know what is the value of pi, and then the only thing that we need to measure is the radius. So we measure the radius with the meter rod or vernier caliper or screw gauge. So but there is a power there. So how do we deal with the error here? So the percentage error, so we have to calculate in the similar way the percentage error, and V is equal to 3 multiplied by the error in radius. So what we have to do, we just have to calculate the percentage error in the same way which we did here, and then we multiply that with the power here. For example, if it's square here, then we have to multiply it with the 2. If it's 4, we have to multiply it with 4. But here it's 3, so we multiply it with the 3.